All right, hello, Professor. So, before we dive into today's session, let me walk you through our agenda. So, by end of this class, you will be able to define what ER diagrams are and understand their purposes, identify entities, attributes, and relationships using real-world scenarios. Explain the two key constraints in ER diagrams: participation and cardinality. Recognize different types of cardinality in database relationships. Also represent these constraints using the look across method and also translate those same constraints into look near method using minimum maximum notations. So since we know where we are headed, let's begin our story. Let's understand what is ERD. Well, it is a short form of entity relationship diagram, which is a visual tool used in database design to represent how data is structured. Well, it actually illustrates how entities, such as people, objects, or concepts, relate to one another in a system. So, ERDs help us model the structure of the database, communicate business rules properly, and better understand the data interactions before the actual database is built. Now, let's understand what are the types of entities. In databases, an entity refers to any real object or concept that we want to store data about, like an employee, a product, or a department. There are two types of entities. Let's be brief about them: the strong and the weak one. The strong entities, these are basically independent, existent, and have a unique identifier called primary key. Whereas the weak entities, they cannot be uniquely identified on their own, so instead they depend on a related strong entities and have a partial key. This classifies this classification helps determine how entities are modeled and related. Yeah. So let's understand attributes very briefly. L- Before that, let's imagine a company. Within this company, there are people. Let's call them employees, and the job roles that define what each person does. Now let's talk about the attributes, which are the properties that describes the entities. The employee entity might have the attributes like employee ID, name, hire date, etc. And the job role entity might could have attributes like role ID, title, salary range, etc. These descriptive details are what we refer to as attributes. In an ER diagram, entities are represented by rectangles. The attributes are represented by ovals, which are connected to the entity by a short line. While these symbols are essential, but for today's class, we'll focus more on how relationships works with the entities. So we'll skip the detailed attribute drawings for this now, and jump to the relationships. So let's continue our story. Each employee in the company is assigned to a job role. This links between employee and job role, the whole thing actually makes a relationship. The relationships are categorized by how many entities they involve, like the binary relationship with a degree 2, where two entities are related to one another, and the ternary relationship with the degree 3, where entities interact all together, like, for example, student, courses, and instructor. And there are also high degree relationships like quaternary do exist but are rare and often modeled using multiple binary relationships for clarity. So, in ER diagrams, relationships are shown as diamond shapes with lines connecting them to the related entities. So, in our example, the diamond would be labeled as assigned to, connecting employees and job role, and also we can rename it as works, which is very suitable for the given example. Now, let's understand the key constraint, participation constraint. Well, this participation constraint answers to the question: do all the instances of an entity participates in the relationship, or just only some? In simpler terms, it tells us whether every member of an entity set is involved or if it is just optional. Let's analyze both sides of our example. On one side, employees. In most companies, every employee must be assigned to a job role, making the participation mandatory. And on the other hand, The job roles, however, might exist without any employees for now, making the participation optional, right? So let's clearly understand the participation constraint on the employee side now. So in the look across method, we show participation constraint on the opposite end of the relationship line. So for employees, we draw a bar across the entity next to the job role, indicating mandatory participation. For the participation on the job role side, we can understand that for job role, we place a circle across from the entity next to the employee, which means the role participation is optional. So the key takeaway is in the look across method, we place the participation constraints on the opposite side of the entity it refers to. So now let's understand cardinality constraint. The cardinality answers to the question how many instances of one entity can relate it to one another. So uh, we can say there are actually three main cardinality patterns: one to one to many, and many to many. Let's briefly discuss about them. So for one to one, each instances of entity A relates to one in entity B. For example, an employee is assigned to one parking space and vice versa, right? And next comes to the one to many, where one instance in entity A relates to many in entity B. For example, the prime example we just took for our class, one job role can be assigned to multiple roles, but each employee must have just one role. And next, but last, comes to many, the multiple instances in both the entities related to each other. For example, employees can work on multiple projects, and multiple projects can have multiple employees, right? That's the basic idea of the cardinality. Now let's understand the employee side of cardinality constraint to our case. In our example, each employee has exactly one role. So in the look across method, we place the number one across from employee near to the job role side, right beside the relationship symbol, which is the standard way of representing the cardinality constraint. Let's see the job role side of the cardinality. Uh, where the job role can be assigned to many employees or even none. So we place M or N across the job role near to the employee entity. So together, this means one employee is linked to exactly one role, but one role may be assigned to multiple employees, right? So now let's understand look near method. So far, we have used the look across method, right? Placing symbols and numbers across the relationship line and from the entity. There's another notation style called look near method, or formally we call it as minimum maximum notation. It is also known as professional practice, where designers prefer this way of representing the constraints to communicate the business rules properly. And also, it is very easy to understand. Let's understand what is minimum maximum notation is. So in the look near method, we place a pair of numbers, minimum, maximum, right next to the entity of the relationship line. So let's understand this. The minimum value shows the least number of relationships required, which ties to the participation, just we discussed prior. The maximum value shows the most number of relationships allowed, that is tied to cardinality. So it answers the question at least how many, or at most how many. So now let's try to apply the minimum maximum notation for our given case. All right. So for employees, we use 1 comma 1 notation. This means each employee must be assigned exactly to one job role. For the job role, we use 0 comma n notation. This means a role can have 0 or many employees. So here's the key interpretation for this. The minimum value, either 1 or 0, determines the participation, which is mandatory or optional, and the maximum value, either 1 or n, determines the cardinality, that means 1 or many. So the minimum maximum notation neatly combines both participation and cardinality into a single pair of numbers placed next to each entity. That's it. Now you not only know how to draw ER diagrams, but also how to accurately express participation and cardinality using both look across and look near method. Thank you so much for this class and time.